What's going on, everybody? I hope everybody had an awesome evening yesterday, and we'll get you guys started on the first page of lesson 11, which I think all of you guys are going to feel pretty comfortable with. A lot of the stuff that we're going to be doing today is stuff that we have done in the past, because the first page is really just a warm-up. So the only one that's not going to be something we've done in the past is part C, because I skipped over it, but I'm going to go through it with you guys today so you guys know what's going on. And then when you guys come back tomorrow, you're going to see that we have 2 word problems of questions that we've been doing algebraically, just not with word problems. So we'll do that tomorrow. We'll just focus on these 3 today. Yeah, and that's about it. So if you guys got any questions, just let me know. As always, you can always stop down to the Zoom or shoot me emails as well. The other thing I gotta ask, if I know most of you guys are watching this on YouTube and stuff, just let me know how the quality is for you guys. Right now I'm running at 540p HD, which is about half. Normally we run at 1080 or 720. So if the quality is starting to diminish on YouTube, just let me know and I'll fix that. Okay. But I'm going to try running it like this because a lot of people are running this on their cell phones and they've been having issues. So I've mentioned it in the last couple videos, but I just want to mention it again. So anyways, I'm going to go through these warm-up questions. Part A says, give a formula for the function whose graph is depicted below. I'm going to tell you guys there's 2 ways that you can do part A. I am going to do it the long way because we just recently did piecewise functions, and this is considered a piecewise function because there are 2 parts. And then I'll show you guys the short way as well. So in this case, if we were to make this a piecewise function, we have to realize that there are 2 different parts of the line going on here, or 2 parts of the function. There is this part right here, and then there is also this part right here. So we got 2 parts, and when we do piecewise, we had to write it with that like little squiggly bracket. So I'm just going to say y equals, I'm going to draw in my squiggly bracket, and we're going to have 2 equations here. We're going to have the blue one, and we're going to have the red one. As far as the blue one goes, we're going to have to extend it a little bit to try to figure out where this is going to be crossing the y-axis. So I just extended it down a little bit, and this is all just kind of an estimate because we're just breaking it down and trying to figure it out by estimating, since I can't talk right now. So if I extend this y-axis down, it looks like we can say that this is crossing, it looks like about 5. So again, it's just an estimate. So we could say it's 5, or I should say -5 since we went down. Okay. So in order to find the equation of that first blue line, it's just y equals mx plus b. Well, we now know the b value. We just have to figure out what that slope is going to be. So again, it's estimating. We don't really know for sure what it's going to be. I believe by looking at this, it's just going to be a slope of 1. And I'm simply just saying, in order to get from this point right here, which is at -2, -3, I'm just going to say I'm going up 1 over 1. And I'm just going to continue that process because I'm trying to make this as easy as possible. So normally I would give you guys a grid and you can count it yourselves. I'm just telling you that the slope is going to be up 1 over 1. And since we're going to the left 1, we can say that the slope of that function is going to be -1. Okay. But because it's piecewise, there's 2 functions, so we also have to find the second one. The second function is going to be represented by the red line, and we already know that the y-intercept for this one is at -1. So again, we just have to find the slope. And just to make life easier for us, again, I'm just going to say that the slope is going up 1 over 1 again. Again, if I give you guys something like this in the future, I will make sure to have grid lines there for you. So since this one's going up 1 to the right 1, we can say that it's a positive 1 slope. Where did it go? So now we have our two equations. The last part that we have to do is just state what the domains are for each one. So in order to find the domains, I'm going to have to erase the color coding that I did so we can go back and look at that original function. And that first line is going off to the left here, and I'm going to look at this and I'm going to say that's going on forever over to the left. So we're starting at negative infinity. And if we continue on this line, we're stopping right here because we extended it to find the y-intercept. The line didn't necessarily extend. So this looks like it goes all the way to -2. So when we go to put in the domain for this first piecewise function, we're just going to have negative infinity all the way up to -2. We also have the red line. And the red line starts down here at that little dot, which is at -2. And it's continuing on. And once again, I'm just going to say that goes on forever and ever and ever. And that would be going towards infinity. So I have -2 is less than or equal to. And I forgot to put in the equal to on the -2 up top. Because it is a closed dot. That is known as your piecewise function. Okay, so that's just kind of going along with what we did the other day. I believe that was what, lesson 7 or lesson 8? That would have been last week. There is a much easier way to solve this one. Some of you guys may have recognized it right away. This is actually an absolute value function as well. Anytime you have a function that is just V-shaped, there is another way you can write it out. And absolute value functions are represented by the bars. So I'm just going to kind of draw a little line because you can get a secondary equation here. When we did absolute value, we had our bars. And whatever was in the bars always came out to be positive. Well, in this specific equation, when you go to look for the number that goes inside the bar, you are looking at the turning point. You're looking at the vertex. And in this case, the vertex is at -2, -3. Now this is kind of going way back to transformations, and some of you guys may not remember transformations all that much, but when you plug in your x value, the x value always goes inside the bars. So I'm going to have an x, and I'm going to have that 2. I don't know why it just did a line like that. And the sign always becomes the opposite when you plug it in the bars. So it'll be absolute value of x plus 2. And that -3 is represented by the y value. And the y value always goes on the outside of the absolute value bars. So I'm just going to put down -3. And the sign stays the same when we do y's. So I know that isn't a problem that we've done in a while, at least the second part of it. The first part we just did last week, so that should look kind of familiar. Doing the absolute value, we probably haven't done that since the beginning of the year, so that's going kind of way back. All right. So I would prefer if you guys are focusing on the top one. But again, some of you guys may have recognized its absolute value, so I wanted to show the second way as well. Both those equations would give you the same result. As far as the next one goes, we have, in this case, would be a composition. I showed you guys this little circle before, but I'm going to rewrite it because you guys are more familiar in its other form. And it looks like that. So these two things are the same. The little circle that's in here is exactly the same as what I wrote right there. So when we do composition functions, you just have to make sure you start on the inside and you work your way to the outside. So our inside in this case is G1. So I'm going to solve that G1 first. So I have G1. That means I have to substitute 1 into the G equation. And in this case, it's just going to be 1 cubed minus 2. 1 cubed is just 1, minus 2 means that we're going to have an answer of -1 for that solution. Now again, we only solve the inside. Now we have to take that answer and plug it into the outside. So now that I have that -1, I'm just going to take it and I'm going to plug it in to the second equation. Why did it change into a straight line? I don't want it to be a straight line. Oh my gosh. 1, whatever. So I'm substituting it in. Well, when I go to substitute this in, it's just going to be f of -1 is equal to 3 times -1 plus 5. And I think composition functions, and I've been checking your guys' work, composition doesn't seem to be too big of an issue for you guys. I just wanted to point this problem out because that little circle is not how we always see it. So I just have to make sure you guys know that the representation is the same. And it looks like this is just going to be -3 plus 5, which will be 2. So based on the composition, that's your answer. You're done. Okay. Part C, again, is going to be a composition function. And this is saying h is equal to, well, if we want to rewrite it so it looks something a little bit more familiar, I'm going to put the f parenthesis g of x. That's all it means. It means the same exact thing. This one, they want us to go backwards, though. So they're giving us an answer, and they want to know what g of x is equal to, and they want to know what f of x is equal to. So it's just going backwards. We've never done a problem like this before. Some of you guys asked me this question on a homework a while back, and I just told you guys to cross it off because a lot of people were confused with it, and I didn't teach it to you guys because I skipped over the lesson with this whole virus thing going on. So I'm just going to do like a quick little mini lesson with it. In this case, since g of x is on the inside, what we're going to do is we're just going to look at h of x, and we're trying to figure out what's on the inside portion of the parentheses. So on the inside portion, it's just the 2 minus 3x squared. So when we go to write down what g of x is, it's just that inside. So I'm just going to write down 2 minus 3x squared. And that's it. So we're just breaking it down and we're just saying what that letter is going to be. The other side is a little bit, I don't want to say difficult, but it's going to be weird because it's only represented by the outside because f of x is on the outside. The only thing that's on the outside here is this 4. And that's it. There's nothing else on the outside. It's just the 4. Well, technically, the parentheses are on that outside as well, and we have that 4. So this little lesson is supposed to lead into something called U substitution. U substitution is used when we start going into something called derivatives. And we will be doing derivatives fairly soon. It probably will be within the next week or two, which according to the way that we're being delayed as of right now, that means it would still be online because as of now, Cuomo said, I think the last day was May 15th is how long this whole stay at home is going on. So we probably will be doing it like the first week of May. But we call it U substitution because we already pulled the 2 minus 3x squared to the outside, or I'm sorry, to g of x. It was on the inside, so we pulled it and brought it over to this g of x. So we don't have anything left on the inside anymore. So in math, we just use the letter U. And it's because we're saying, hey, we're saying U is being substituted in for 2 minus 3x squared. Now, it seems kind of tedious to do that for here, but when we go into this thing called derivatives, we might be using U substitution for something that's very large, and we don't like rewriting everything all over again in math, so we just plug in the letter U to save some time. So as far as the two equations go here, g of x is represented by 2 minus 3x squared. F of x is just going to be represented by u to the fourth. Okay. So that's all I'm going to do with you guys today. Just some warm-up questions. I call them warm-up. It would have been warm-up if we were doing it in class. I guess they're just kind of review questions for the most part. When you guys check out tomorrow's lesson, you guys will see that we're going to do some word problems. I'll go step by step. I'll draw some pictures. I'll make sure that you guys feel pretty comfortable with those, and I'm sure you guys will be all right. Okay? So I'm going to end it there. I hope you guys have a great evening. Let me know again if you guys are having any quality issues. It's really going to be for only people that are not watching this on their cell phones. If you're watching this like on a computer, or if you're watching it on a laptop or something like that, it may be a little blurry for you. Just let me know, please, so that I can fix it for you. All right, so I will catch you guys later. Hannah, see you tomorrow. Anybody else that was in here, I will see you guys tomorrow, or I'll talk to you guys through email or however I've been contacting you. All right, have a good one, guys.